Hello and a very good afternoon to everybody. I'm delighted to welcome you to today's presentation on BIM model performance assessment and data analytics. In the context of BIM, building information modeling, the ability to effectively evaluate model performance and harness data analytics is of paramount importance. In this session, we'll delve into the specific challenges and opportunities surrounding BIM models. Furthermore, we'll also highlight the critical role that data analytics plays in extracting actionable insights from the BIM data. By leveraging data analytics, professionals in this field can uncover valuable information, optimize construction processes, and enhance project outcomes. And most of you will bear me witness on this one. So please join me as we dive deep into the BIM model performance assessment data analytics, equipping you with the knowledge and tools necessary to excel in the dynamic world of BIM. A brief introduction about SNC and where we are. So SNC-Lavalin is a world leader. Founded in 1911, SNC is a global, fully integrated professional services and project management company and a major player in the ownership of infrastructure. On July 3rd, 2017, SNC-Lavalin acquired ATKINS, one of the world's most respected design, engineering, and project management consultancy firms. We have an established and balanced footprint that spans across from Americas to Europe, Middle East and Africa, and Asia Pacific. We are approximately 50,000 employees working in offices in over 50 countries. We take pride in our unmatched value chain that spans from capital and operations and maintenance and sustaining capital as well. But for this particular presentation, we are here to add value from our digital capabilities. A brief about myself. My name is Anthony Nzoka, and I'm an information manager in ATKINS, a member of SNC-Lavalin. I'm an engineer and a digital transformation enthusiast with 8 years of experience in implementing various digital transformation initiatives in multidisciplinary projects across different global markets. I have excellent reputation in information management to international information management standards, ISO 19650, and I've been dedicated to optimizing the management of information across projects, ensuring they align seamlessly with ISO 19650 standard. My expertise encompasses the entire information cycle, from creation and organization to distribution and maintenance, all while adhering to principles outlined in ISO 19650. I take pride in the ability to collaborate effectively with multidisciplinary teams, bridging the gap between technical aspects and practical implementation. My proficiency extends to employing cutting-edge software and technologies that facilitate streamlined information exchange and enhance project outcomes within ATKINS and SNC-Lavalin. I've been involved in employing various digital tools and spearheading BIM task forces through training, representation in BIM roundtables, digital transformation and construction conferences. I also form part of the Autodesk Certified Professional family and joining the BRI Academy for ISO 19650 Part 1 and Part 2 Task Information Management and Project Information Manager certification. So diving into the actual presentation today about model performance assessment and data analytics, I'd like to highlight one critical item, which is quality assurance during the design phase of the project. We all understand that quality assurance begins with a single discipline and multidisciplinary steps of the BIM model sharing process. Fundamental to the quality assurance process for BIM sharing as part of information management is the creation of evidence of the checking that has taken place in the BIM model or in the overall process. To support additional quality audit process beyond the scope of ISO 19650, it is critical that such evidence is complete and that it is accessible to support onward reviews and finalize client deliverables. This affirmation of evidence completion and availability ensures an efficient quality audit can be conducted and that the delivery of this ultimately meets the project information standard. So how do we do this? This is carried out by extracting quality assurance data from the BIM models to ascertain model health, proper coordination, accuracy of the design data, both geometrical and non-geometrical, and we also ensure that we have a data-driven design management through automation and data breakdown and analytics, which is coupled with the key performance indicators aligned to the project information requirement. To achieve this, ATKINS has been developing solutions to enable data-driven project delivery. And over the last 2 years, we have created a suite of dashboards which draw upon data from BIM models and the common data environment to provide insights into the various aspects of delivery. So this suite of dashboards enables project teams to improve the quality from the BIM models through rule-based checks, manage the flow of information in the common data environment, enable the extraction of quantities and visualize model build-up and design development through the BIM models, and streamline multidisciplinary coordination through the visualization of clash detection reports. So project teams are empowered with data so that they can make informed decisions, measure progress, have transparency in delivering, and in the end, deliver better value for our clients. The data which we utilize to build these dashboards come from a variety of sources. And this includes BIM authoring tools like Revit, Civil 3D, Plant 3D, and other open suites of products by Bentley. It also comes from CDEs such as BIM 360, Autodesk Construction Cloud, and also ProjectWise. We also fetch data from federation platforms such as Navisworks for model build-up and coordination from Navisworks as well. And sometimes we use spreadsheets that we utilize to log risks, RFIs, and comments during the design development. So each data source requires a secondary set of tools to extract data, and even for the same source, we sometimes have to rely on different extraction methods to get the data we need. For example, for Revit, we depend on Autodesk validation tool to extract the quality data. For quantity and model buildup, we usually rely on visual programming, which is Dynamo, as most of you know, and a task automation platform called Clarity Server. Depending on the scale of the project, we sometimes adopt different approach for quantity takeoffs and model buildup, relying on the federated model in Navisworks and a plugin called iConstruct. The extracted data comes in a variety of formats, including spreadsheets, databases, and complex XML files. This data is then structured and processed using macros and Power BI to feed into our dashboards. In the future, SNC and ATKINS is working on an integration with our data ecosystem, which is a single source of truth, which will allow us to have a unified pipeline for data ingest, processing, and access. With all the heavy lifting shifted to the cloud in most of the projects, we will be able to integrate all sources of data with the data ecosystem serving as a gateway to data for BIM models, etc., and every other particular deliverable in the project. So the complexities is shifted to the data ecosystem and agnostic of the authoring tools and versioning, which is managed automatically within the CDE. So we focus on the project data, both at project level and at a sector or business or regional level. However we want to aggregate the insights, however you want to do it, we can be able to visualize this particular data. It will draw all corporate data via ORBs, where this enhances the insights. So to dive into one of the dashboards for data analytics is a clash detection dashboard. And we have deployed dashboards to provide analytics from the common data environment in ACC or BIM 360, so that we can keep sight when information is being generated, updated, and shared. We also check compliance to the standards defined within the project, and the dashboard allows us to make sense of the large data sets, which comprise of thousands of files to get to the information we need without having to sift through a trove of data, as you can see, as most of you know. So regularly conducting these checks on the common data environment and verifying data, the model status is a very pivotal in the modern construction and project management environment. So the CDE serves as a centralized repository for project data, enabling seamless collaboration and information sharing among stakeholders by monitoring document and model statuses within the CDE. Several critical advantages are actually realized. First, this practice ensures that we have real-time visibility on the project's progress. So accurate and up-to-date status information enables the project managers, design directors to make informed decisions during the project delivery. So they can promptly allocate resources, they can make decisions promptly, and they can address potential bottlenecks when they they want to escalate or before they escalate those particular bottlenecks. So this aids in maintaining project timelines and mitigating delays in the project. So on this dashboard, we are able to visualize the summary of all the files that we have in BIM 360 that will enable the project manager to see how the project is growing, the number of models that we have in that particular project. It also shows data analytics on the duplicates of files that we have in BIM 360 because we have the same files with the same naming convention, with the same file type, which is put in different information management containers and work in progress, shared, or archived folder. So we're able to drill down into every particular aspect of the information management container, whether it is work in progress or shared or published folder. We're also able to visualize activity logs within the within the BIM 360 to see what activities are actually happening within the CD without necessarily going to the CD itself. So we're able to see who has opened files, who shared transmitters. We can see number of transmitters that have been shared through this particular dashboard. We're able to also look at the review log, which is a rule of credit in terms of the completeness of this design deliverables. So we're able to see the number of reviews. We can see which reviews have been completed, which documents have actually been initiated in the review workflow, who is that particular project team member has initiated these documents in a review workflow, and who added these files and which files have been added. They're able to drill down into this data through this particular dashboard. We're able also to look at the progress. So we're able to see the progress monitor when the files were shared, when they were shared, or when they were published, and when those files were exchanged between one state to the other. We're also able to drill into the files themselves within the same dashboard. We can go into the main folders or the information management containers on the bottom right there, work in progress or published or shared or archived. And if you go to any particular folder or any particular information management container, you're able to drill down into the discipline-specific folder and see those files which are in that particular folder. So we can also assess whether the name is correct, whether it is compliant to the naming convention, whether you have a duplicate of the same file, and the number of times that file has been duplicated within that particular folder. So this is data that is coming from the CD that the project managers, the design managers, the design project leads are able to visualize. Next is on the model health dashboard. So we are also able to extract data on different models in terms of the model health to visualize in terms of the links, in terms of the model views, in terms of CAD links, imported CAD links, what type of files have been linked there, if you have raster images. And this is very critical to measure as a rule of credit, to measure the quality of our models that we're submitting to the client. So we're able to drill down into every individual model there. Click it, you can see the number of unpinned Revit links, you can see the number of nested links. We're also able to drill down into the model checks themselves. You can go to every particular model and see what files are linked into it. You can drill down by discipline, or in terms of the stakeholders, you have partners or within ATKINS. And this is fetched from the naming convention of that particular file. If it has ATK, for example, as its originator, then that is mapped into AWS ATKINS models, and you're able to drill down into those particular models. We're also able to see the model checks in terms of the assemblies, unused families, which forms a greater percentage of the quality of the models. We are able to look into the views, the number of views which have been which are placed in the models but are not used, which are not published, the types of files or families which have not been used, the percentage of those files or percentage of those Revit families which are not used. In terms of views, we are able to see the number of views which are in that particular model, what is the name of that particular view, and what is the element ID for those particular views which are not included. We're also able to drill down into every particular Revit model in terms of the model quality, the number of links, warnings, work sets and phases, and also check the project coordinates, and if the file has all the files have they have the correct work sets, all the work sets are properly named, and all the elements are actually assigned to those particular work sets. We're also able to show in terms of the project coordinates. We're able to drill into the project information, see the project details there for a particular model, see the inaccuracy of the coordinated data, and this is just for purposes of showcasing. But we're able to fetch all this data, and by just looking at this particular dashboard, you're able to see the quality of the models. This data is coming from the data analytics, or the data is harvested from. So in order to perform the clash detection, we have a defined clash matrix per building in some of the projects. Could be per area, could be per asset. And once the matrix is created, we use the automated workflow to set up the clash tests in Navisworks. With this setup, then we are able to perform the clash detection on a weekly basis, and the clash results are compiled into the dashboard. So the dashboard, again, we've created this clash detection dashboard that provide analytics broken down based on the area, level, discipline, and this provides the teams with insights and support to resolution of clashes. We have in-depth analysis for individual tests to identify the trends and patterns to preemptively determine areas of focus within the model for the teams to work upon. So analyzing and visualizing clash detection results is very crucial in the construction and design projects to ensure smooth execution and high quality outcomes. So clash detection identifies the conflicts between buildings, elements, like structural components, mechanical system, and architectural features. So visualizing these clash detection results provides a clear, intuitive way to comprehend the extent and severity of these conflicts. This aids in effective communication amongst project stakeholders, including architects, engineers, contractors, and sometimes even the client. So by visualizing these clashes, teams can quickly grasp the spatial relationships between elements and make informed decisions to resolve these conflicts before the construction actually begins. So incorporating this clash detection analysis into building information modeling workflows, into our BIM workflows, enhances collaboration and coordination amongst disciplines teams. The visual representation of clashes and analyzing these numbers and data, facilitates better problem solving, as it enables the stakeholders to proactively address conflicts and optimize the design solutions. So in essence, the importance of analyzing and visualizing clash detection results lies in its ability to enhance project efficiency, reduce rework, and foster effective collaboration, and ultimately resulting into successful project outcomes and client satisfaction. We have rules of credit, which is part of our master information delivery plan. So we have a master MIDP online tool, which provides a rule of credit in terms of the project development and the progress in the project. And this is accessible across by all the project stakeholders. So the BIM models play a significant role in implementing and enforcing the rules of credit when measuring the project progress. So BIM is a digital representation of the physical asset, but the development of the deliverables and the registration of the stage of completeness for this deliverables is actually incredible to the project managers to be able to measure and to be able to report what number of deliverables we have, which deliverables are due, and which task teams or which particular task information delivery plans are actually not covering or not ready for submission. And this is within the ATKINS and SNC-Lavalin. Into the future, we're looking at integrated data ecosystem where all this information is integrated into one data ecosystem, which will allow us to have a unified pipeline for data ingest, as I mentioned earlier, and processing and access with all the heavy lifting, shifted to the cloud. All the data is accessible to all the project teams. So in this dashboard, we're able to see, we're able to drill down, as I said, whether it is a project level or the sector level, a business or regional level. We're able to drill down into every particular project with the data, which is centralized and harnessed through the same process I've described before. We're able to centralize all the information. So we're able to see the quality score for the project. We can see the trends and the level of coordination for any particular project. We're also able to see the number of RFIs and issues raised in that particular project. We also to see the delivery performance of that particular project, whether we are on time, we have reworks, or we are delayed, and what is the percentage of completion for this particular deliverables. And all this data is fetched from a central source of truth. We're also able to check the compliance and the number of model elements as a model to continue to develop what number of components we actually developing. Thank you very much, and should you have any question, please feel free to drop them to me or to the event organizer, and we'll be able to respond to you in due course. Thank you very much, and thank you for listening to me.